Welcome to our 8th grade pre-algebra flipped lesson. This is section 1.3 and it's solving equations with variables on both sides. Along the way you may need to pause the video to do some math problems that I should see in your notes. So tomorrow we'll grade your notes, so please take notes carefully. If you need to, you can pause to catch up and to solve those problems. So solving equations with variables on both sides. There are some steps we're going to take to do these. So, next page. So the steps. So first step is to simplify both sides of the equation. So that means on either side of the equal sign. Okay, our second step is going to be add or subtract to place variables on one side and numbers on the other side of our equation. The third step is to multiply or divide to isolate your variables. Okay, so now I'm going to give you some examples to help show that. So example 1. We have r equals negative 5r plus 18. So we want to first simplify both sides of our equation. Both sides are simplified, so we don't need to do anything. Now I want to add or subtract to get my variables to one side. So I want to try to get my variables to the left and keep my numbers on the right. And I'm doing that because this negative on the right, if I add 5r to each side, I get some nice positives. So then I get 6r equals 18. Next I'm going to multiply or divide, and since this is 6 times r over here, if I divide both sides by 6, and I'll show I'm going to cancel those, so then that says r equals 18 divided by 6, which is 3. Alright, that was a simpler example. Here's example number 2. So I have a lot more going on number 2. You know what, I'm going to redo that so that you can actually read my writing. So I'm going to go to my steps and I want to simplify both sides, and I see that I have some parentheses on both of these sides, so I want to get rid of those because I'm going to follow PEMDAS. So I'm going to distribute my 6 to everything inside of that first one. So I'm going to get 6 plus, I know half of 6 is 3, so I'll have 3x equals, and I'm going to distribute my 2 into this parenthesis, so now I have 2x plus 2. Okay, now I'm going to look and see is there anything I can combine on the left or to the right. I'm just drawing the line to keep things organized. Everything's pretty good, and I notice that I have 3x on this side and 2x on that side, so I know if I subtract 2 x's, I'll still have an x on this one side. So now I have 6 plus x equals 2. I'm going to subtract 6 from each side, and I'm going to have x equals negative 4. Okay, now I need you guys to try some on your own. So in your notes, I need you to try number 1 and I'm going to number it number 2. So tomorrow when I look at your notes, I should see that you've tried to solve these. I should see all of the work that got you to your answer. It's a Z. Okay, so go ahead and solve those. When you're done solving those, unpause the video. So pause the video, solve them, and unpause the video when you're ready to move on. Okay, we're going to be ready for some more examples. This is example number 3. So I'm going to try to clean up either side. Both sides are fairly clean. So now I'm going to subtract 3x from this right-hand side. Oops. I made a mistake. Sorry, this should be a plus 3x. So now if you notice, if I subtract 3x from both sides, I'm left with nothing equals 7. So there's no solution to this problem. So sometimes you might just write no solution. Here's another example. So I'm going back to my steps, and I first need to simplify the left-hand side. So I want 1/4 of 8x. So I need to distribute. So I know 1/4 of 8 is going to be 2x. I know 1/4 of 12 is 3. And if I look at this, they're exactly the same. So no matter what I say x is, it's always going to work. So this one has an infinite number of solutions. I can use any number I want to solve this equation. So sometimes you might have no solution, sometimes you might have an infinite solution. So now I'm going to give you 2 examples to try. So we're going to just number this number 5. So you're going to pause the video again. You're going to try to solve these, and you're going to figure out which is infinite, which is no solution. And we'll go over the answers tomorrow. Okay. Okay, so now we're going to do kind of a word problem. So we're going to use the example that they use on page 6, example number 6, but I'm going to change the numbers a little bit. So if you want to turn to page 22 in your book, that might help. So it says a boat travels X miles per hour upstream on the Mississippi River. On the return trip, the boat travels 2 miles per hour faster. How far does the boat travel upstream? And they give you an equation. So they say that, well, first of all, you know the distance upstream has to equal the distance downstream. So distance up has to equal the distance down, right? And we also know that speed equals distance over time. I always think about when I'm driving my car and I go miles per hour, so that helps me to remember distance over time. So that will help me as well. Okay, so we know that our distances have to be the same. So we know distance has to equal distance. So then we could also then kind of, if I rearrange this equation, I know that distance equals speed times time. Because I know my distances are equal, I know that the time and the speed going up must equal the speed and the time coming back down. So now I know my speed and my time going up must equal my speed and my time coming back down. So I'm going to go back to my equation, and it says the boat travels X mile per hour upstream. On the return trip, the boat travels 2 miles per hour faster. Also, if you look at the picture to the left, it says that to go upstream takes 3 hours, but we don't know what the speed is. It's what we're trying to find. And it says the time coming back down was 2.5 hours, 2.5 hours, and we know that they traveled and we know coming back down they traveled at 2 miles per hour faster. So because we said speed was x, we know that they traveled 2 miles per hour faster. So now we're going to solve. So the first thing we need to do is distribute this 2.5 into that, and I'm going to get rid of my parentheses on both sides, and I'm just going to say 3x equals 2.5x plus 5. Okay, so now I'm going to subtract my 2.5x's from both sides. I'm left with 0.5 of an x equals 5. So that's really like a half, but if I divide each side by 0.5, I know that it is 10. So the boat travels 10 miles per hour for 3 hours upstream, so it travels 30 miles upstream, so we could figure out. So tomorrow during class, we'll work the problems, and we'll see how this flipped lesson goes.